Okay, we're going to start our constructions by reviewing the properties a little bit. This question asks us to do a square inscribed in the given circle. Inscribed means it needs to fit into that circle perfectly with one vertice, or all four vertices touching the outside of the circle. So the properties that are helpful in this construction are listed right here. We need our diagonals to bisect each other. They have to be perpendicular and they have to be congruent. So I'm going to start by drawing a diagonal to this square. If this is a diagonal to the square, I need another segment that is congruent to it. Well, all other diameters are congruent, so that's easy. It has to be perpendicular to this and it has to bisect it. So we need to construct the perpendicular bisector of that segment. Let's get my compass. To do the perpendicular bisector, we set our compass to more than halfway. I'm going to set it to the full length of the diameter. You don't have to do that, but I like to. And we're going to draw an arc from each endpoint. Scroll up a little bit. From the left and from the right. And we're going to connect those intersections. And that gives me the other two vertices of my square. So now if I connect those 4 points, I have a shape whose diagonals are congruent, they bisect each other, and they are perpendicular, which guarantees that my red shape is a square. The second construction asks us to make a rectangle inscribed in a square. So for this one, technically, you could do the same exact construction we just did because a square is a rectangle. However, for a rectangle, our diagonals just have to be congruent and bisect each other. That perpendicular piece is gone. So if I draw this guy, any other diameter I draw, no matter where I draw it, is congruent and it bisects that. I'm done. I don't even need a compass. I have diagonals that bisect each other and they are congruent, and therefore I have a rectangle. Done. Next construction asks us to construct square ABCD, and now they gave us side AB, and we have to complete the square. There is more than one way to complete this construction, so I'm just giving you a sample solution, not the solution. The very first thing I'm going to do is extend my segment a little bit. And I know that in a square we have 4 congruent sides and we also have 4 right angles, so the first thing I'm going to do is make a right angle at A. To make a right angle at A, I'm going to draw an arc, whoopsies, on either side of A, so that now A is the center point of that arc. Next, I'm going to do the perpendicular bisector of that segment that I just found. So I set my compass here, do an arc from the left, and also from the right. And when I connect these, I'm going to get a line that goes, I don't like that color, I'm going to get a line that goes right through A, and it's perpendicular to AB. So there's the second side of my square. Now to find out where the length goes, this part's not too bad. We just measure the length of AB. There we go. And our vertical side has to be the same length. So I'm going to copy that measurement right here. And that's going to be one of the points on my square. Now from here we do have options. I know that some people actually like to just kind of repeat that process and put a perpendicular right here and do the same exact thing. That works. It's totally fine. But I'm going to use the fact that in a square all of our sides are equal. So if this is the length of AB, I'm going to use that to say that up here we have to have a segment of the same length. And now that's also the height of that side. So if I measure from here, that's the length, and where they intersect is the 4th point of my square. Switch to red. And I have square ABCD. Now I'm not looking at full credit right now because I didn't label it ABCD. So that's point C, that's point D, and now I have square ABCD. Okay, Rectangle ABCD. Well, this one, they're pretty generous because they gave us 3 out of the 4 points of this rectangle, so we just have to find the fourth. We could make a right angle over here at B if we wanted to, like we did in construction number 3. That works, great, go for it. Another option is to measure the length of AB. So there's the length of AB. Now the segment parallel to it has to have the same length. So from D, we have to go that same distance. And then I measure AD. And the segment opposite it has to have the same length. So B, we're going to have the same length segment here. And where those meet has to be my missing point. So if I connect these, I have found the missing point, which in this case is point C. And it's one way to do it. Other ways could work, but that gives me rectangle ABCD.